Cordierite is a magnesium silicate material that's synthesized by a solid-state reaction method that consists of high-purity powder of magnesium oxide, aluminum oxide, and silica. The powder was mixed according to the stoichiometric ratio of cordierite. This experiment is conducted to examine the characteristics of cordierite materials with two different percentages of sludge. The percentage of sludge that used in this experiment is 0% and 95%. The testing that involved in this experiment are dilatometer, X-ray diffraction, XRD, and morphology by using scanning electron microscope, as known as SEM.
For SRD diffraction result, the phase identification of SRD pattern and read back refinement analysis of sample with according to the stoichiometric ratio of cordierite formulation of 2.8 MgO, 1.5 Al2O3, 5 SiO2 synthetic at temperature 1250 Celsius for 2 hours as dwell time. The phase that exists in the sample 1 and sample 4 are alpha cordierite, pentapotassium triantimonidostenate, and diantimony molybdate. At 1250 Celsius, the alpha cordierite was the dominant phase for sample 1, while the pentapotassium triantimonidostenate for sample 4. Based on the SRD testing, the intensity for S1 and S4 are very low due to the fast in skin rate. If the sample have a minor phase, the highest peak will be diffracted, but certain peak will do not diffracted. And here is the crystal system and the space group that exists in the X-ray diffraction pattern.
For the S1 sample, the quadrate height has the strongest peak that diffracted is at plane 010, which is 10.431 degree, and the second strongest peak is diffracted at plane 121 with 29.458 degree due to the higher intensity at first peak. Next, for pentapotassium triantimonidostenate, the strongest peak is diffracted at plane 11-4 with 21.562 degree, and the second strongest peak is diffracted at plane 006, which is 49.2. No peak diffracted for diantimony molybdate at any plane. Then, for the S4 sample, no quadrate height is diffracted represent in the sample because the higher scan rate and lower intensity. For pentapotassium triantimonidostenate, the strongest peak is diffracted at plane 122 with 28.023 degree, and the second strongest peak is diffracted at 11-4, which is 21.562 degree. The diantimony molybdate, the peak is diffracted at plane 04-2 with 32.518 degree, while the second strongest peak is diffracted at plane 300, which is 26.833.
As the analysis for dilatometer testing, after 50 degrees Celsius, shrinkage was detected. This is due to a change in the atomic structure known as the Curie point. Curie point is the temperature above which certain materials lose their permanent magnetic properties. At 100 degrees Celsius, the sample creates an asymmetric curve. It means that the quadrate sample increasing in interatomic separation and thermal expansion. As shown in figure above, the mean interatomic separation increases as the energy associated with the vibration of the atoms is increased. The sample continues to expand until it reaches 249.2 degrees Celsius, which is 7.2 CTE. Then an increment of the shrinkage rate at 750.1 degrees Celsius, which is 0.6 CTE, was observed and attributed to a change in the mechanism operating a sintering in presence of a liquid phase. The very slow shrinkage rate up to 750.1 degrees Celsius was associated to a solid-state sintering. Quadrate samples have a low thermal expansion coefficient because to its relatively stiff tetrahedral framework and the anisotropic expansion of the octahedral framework of the quadrate structure.
The above shows the SEM result on S1 with 0% of sludge. It shows the particle size of quadrate sample. The particle size is smaller and differ to each other. As for the next figure, it shows the SEM result on sample S4 with 95% of sludge. It shows the particle size of quadrate sample. The particle size of sample S4 is larger and differ to each other. Next is the figure of SEM result on sample S1 with 0% of slush that shows the grain size of the quadrate sample. The grain size for sample 1 is smaller. The figure of SEM result on S4 with 95% of slush shows the grain size of the quadrate sample. For sample S4, the grain size is larger compared to sample S1. According to SRD result, the phase that present is alpha quadrate. At alpha quadrate, it shows the fine microstructure is formed over the surface of the sample. The microstructure that present is practically fully dense at temperature 1250 degrees C. The sample S1 with percentage of 0% slush shows a fine microstructure with less presence of porosity and fully dense body with better appearance contrast compared to sample S4 due to the small size of the grain. In contrast with S4 with 95% slush, it shows a larger particle size and grain size. On the report of SRD result, the phase that present on S4 is pentapotassium triantimonido stannate. The microstructure of sample S4 is more porous and less dense compared to S1.
In summary, the characterization of sintered chordierite had been successfully identified by using dilatometer testing, SRD testing and morphology testing. The coefficient of thermal expansion for sintered chordierite decreased respectively. In terms of phase identification and chemical composition, SRD result revealed phases that exist in sample 1 and sample 4 are alpha quadrate, pentapotassium triantimonido stannate and diantimony molybdate. The dominant phase is alpha quadrate for sample 1 and pentapotassium triantimonido stannate for sample 4. Lastly, for morphology analysis, sample 1 with 0% slush obtained densified body and less presence of porosity compared to sample 4.